My challenge is to get you to talk. Recording? Are we recording voice too, or are you just recording anything? No, just taking notes, right?
No, recording as well.
We're recording as well? Okay.
The audio?
Yeah.
It's good to know you're being recorded. All right. So the challenge here was to, at the end of a long day, to talk a little bit about some emerging topics and in natural hazard research, particularly focused on things that would require experimental kinds of research. I mean, at the end, you know, we're not just approaching this from the point of view of natural hazards engineering, but thinking about it in the context of the experimental facilities. So it's okay, I think, generally for us to think about the emerging topics and the key challenges, but eventually thinking about how our facility or even other facilities that we saw some discussion of today might be used to address these challenges. So I really have no plan except knowing that I'm standing in a room of very smart people and thinking that these are questions which are sort of big questions. I'm going to actually throw it open to people. Chimoy is going to take some notes, so you'll see some discussion. We're going to try to break it up into three questions. What are the emerging topics that are in natural hazards and their effect on infrastructure that are of importance to us or of interest to this group? What are some of the challenges and needs with research? And then how can our facility or another facility, we don't have to limit it to just us if we want to think more broadly about that. How can these facilities be utilized to perform research on these topics? So we're going to just go to the next one. Chinmoy will type ideas that might come up, but what are some of the emerging questions and topics?
So mine is, I don't think it's emerging, but it's more of like some kind of changes made to existing stuff. My research area is in it's kind of a modification on the semi-active stiffness damper. We call it the semi-passive and the passive. So there's two steps. The first step, we try to come up with mechanical properties. So we'll eliminate the RSASD knowing when to release all the energy it's collecting. So my device has, it uses its own mechanical properties to determine when it needs to open and close. And then finally, we've moved all the way from that to there's no electrical component at all. So it's all passive. While, I mean, it's still it's not completely passive, but it's still reacting to based on the needs that it has. So coming here, I just started my PhD. I did this for my master's. We have simulations, and then we also have experimental stuff. Right. So the next step, because all we tried to do was do a proof of concept to see if it worked. Right. So the next step is try to get funding for maybe put in a building or something like that. And I think it would be really great to collab with.
Okay. Yeah. So it seems like there are a lot of really good ideas out there still on new, we call them like response modification devices. Yeah. I mean, Danforth's been around for a long time, but there's always many new ideas about that. I saw something recently when I was in New Zealand earlier this year, different kind of like a viscous damper that has some different characteristics. I think there's a lot of interesting ideas out there still. So I guess response modification devices generally are still, there seems to be a lot of opportunities there to improve the performance of structures.
Something that's come up a few times today is not just looking at planar motions, but actually vertical components potentially to ground motions, or even out of plane loads on frames. Right.
Focusing on
3D, and then how do you codify a vertical spectral acceleration?
No, in the shake table test that Robert Fleischman talked about, Jose designed that structure specifically so that would be torsion, even though the table was in one direction, just so we could see all the structural components behaving under some true 3D kind of torsion. Yeah, intentionally created the torsion. I think that's a good
thing. But even does the vertical.
Vertical, yeah. And so once you have multi-group tables, you can do more of that.
Coupling multiple hazards to get it in the lab. So
yeah, multiple hazards, right?
Coupling something that even that you've got sometimes numbers. So.
Right, multiple hazards, yeah. And I guess one that seems to be of interest but is challenging was fire following earthquake, right? But there's a challenge. NSF doesn't really want to deal with fire hazards. Yeah. Other ideas? Yeah.
I did talk to the Florida guys. I think they're really interesting.
Yeah, sure.
Because and whenever wind, you can think about it, it's actually modest scale. The typical is they can do a wind tunnel, which is smaller scale.
Right.
But yeah, this is just mass. You just get some magnitude and get it here and just the real thing. But it's hard to fit back to wind tunnel. Maybe just one more you don't have.
Mm-hmm. Yeah, I think it's a very good topic. Yeah, we had some interest in that when we first wrote the proposal for this NHERI equipment facility, experimental facility, but it didn't make it to the final part.
But is there a mechanism just talk to the Florida guys? And
Sure.
Like I think Forest Master is very kind of out of the box.
Mm-hmm. Yeah, it's a good idea. Other ideas?
Are we concerned about sea level rise issues on the East Coast and the flood loading that creates hazards and stuff like that?
Mm-hmm.
And then how do we really improve the strength of existing structures and have better designs for the future? Probably at least for retrofitting, particularly for sea level rise issues.
Right. Yeah, definitely. Mm-hmm. I think natural hazards and the climate change, in the context of climate change, is actually very important.
One other thing that I was thinking about was the homeland security driven progressive collapse, the unified facilities criteria evolving in time. And they have very loose guidelines, well, general and loose, how do we really retrofit buildings. No really heavy duty substance to their stories. I mean, it's some guidelines, they tell you have to do it, but the methods are missing. I'm not missing, but grossly underdeveloped. So, for example, like the kind of attack we had in 9/11, they're highly unlikely, but somebody upset with IRS was flying and ran into a building. And so, is that considered it's hazard? But is it natural hazard?
It's not a natural hazard. You might say it's an unnatural.
Is that outside of the? Is that outside of the domain?
Buildings is unnatural.
Is it outside of the domain?
Well, I think it's outside of the domain maybe of what NSF is funding under the NHERI program, but I think for people in this room, it's probably still of interest. It's definitely a hazard, and in the multi-hazard context and stuff.
Would we say that it's natural for people to get upset and do bad things, and they do that?
I think it's unnatural.
Natural in that sense.
To take it that far, actually. But
I'd be stretching.
I think it's certainly of interest to people, and there's been some experiments in our laboratory on looking at mitigating progressive collapse or providing increased structural integrity. But there's probably good suggestion. Other suggestions?
Hurricane resistant design because of stuff coming from Florida and hitting everybody along the East Coast.
Yeah.
Would that be
Wind?
wind?
I think there's
Hurricane
wind. Yeah.
I think sustainability probably is an important one too, either through material innovations or tying architecture with structural engineering a little bit better. And NSF is doing that already. Architecture is part of CMMI now. But trying to improve energy efficiency of buildings, that's something that structural engineers have neglected over decades.
Right.
Hey, Richard, structural health monitoring.
Hardly emerging. It's not really emerging, right? But if it's important,
The aspect about actually, I guess you say condition assessment, and perhaps even having a smart structure that tries to offer alternative load paths or tries to heal itself. Or like early warning, something of that sort.
You have to actually start a little slide. It gets so small. Yeah.
That's 15. Okay.
Yeah. Well, I'm just saying soon.
Yeah.
Other suggestions?
Along with the sustainability of it is the testing energy efficient materials are already out there. Making sure that they're actually structurally reliable for rising hazards on this. Right.
Yeah, the whole area of
Structural and
non-structural things and structural things working together somehow. So,
Reliable, right?
yeah.
Viable.
Yeah.
The same. Yeah. Same.
Yeah.
I think residential buildings would be one of that too. Yeah, I mean, especially if we talk about sustainability, there's more projects now being done on wood frame structures. Right. It could even be concrete residential buildings, why not? So there's work that can be done.
You mean that single family or you mean multi-family?
It could be multi-family or single family. I mean, we've focused so much on, these big buildings, and even though they're the most impressive in terms of actual impact, I think they're probably not the biggest impact.
I think it's very interesting that you mentioned concrete residential buildings, where in other parts of the world, I'm from Ghana, that's all we do.
Yeah.
It's all in the US, mostly wood, and that was a huge difference for me. It's very interesting that we're going back to that as a possible thing.
Well, of course, wood is doing the same thing, and they're going into multi-story construction. So, I mean, they're going into what we've seen as reinforced concrete or steel medium over the many years. Now they're doing that, and we may want to go in the other direction. Put our foot into the residential construction.
Is there room for new retrofitting methods that people haven't thought about before? Innovative retrofitting methods?
Always, yeah. And I think especially, we tended to avoid the really difficult retrofit problems. Unreinforced masonry, for example. It's not a lot of easy ways to retrofit that efficiently.
A large number of bridges in the United States have corrosion damage, and that's one area where people don't really pay too much interest in. But I haven't seen very many engineers.
And it is at no fund bridges. It's only for the federal
Corrosion
highway.
is not national.
It's a federal highway or state.
I see.
If it's WA or something.
Right.
Maybe something to clarify with Joy tomorrow though, and see if that's something, even though it's another federal agency, is something that can still do within area. Different funding source, but still do this in every project.
They're pretty adamant about marriages at this point.
Yeah, we used to do NHERI flag projects. Like the two projects I showed you, the bridge columns that were NHERI flag. So we donated the data and they allows us to I don't know what the policies are.
Actually, I don't know. It's a good question.
Yeah.
I think to be clear that you're not asking about funding the research, but you're asking about the availability of your facilities.
Yeah, exactly.
Work. I think that's a very good question to ask.
Yeah, I believe the position is if it's NSF funded,
No issue.
no issue. If it's other government funded, they're proponents of it, but it doesn't qualify as a right. At least that's what it was when this rolled out less than a year ago. That may have changed.
Church different rates.
I don't know. That's the question to ask, really, in terms of what are the rates for equipment use and things like that. It's federal funded, but not NSF funded. That's a good question.
Yeah, there's clarity rates because they don't want NSF paying for benefits of these other agencies, because each one gets a congressionally mandated budget to spend on their research agenda. So
This is a question for tomorrow, right?
I think it's a question.
Yeah, question for tomorrow.
Oh, yeah.
Okay.
So what about irregularities? So we test all these structures that are really normal all the time, right? It's, 3 bays tall, really clean, continuous lateral force resistant system.
Right.
Irregularities are complicated. And
I think the other, computational simulation, there's this aspect about models, and especially computational models and accuracy, and trying to quantify sensitivity to imperfections in the model, either through the data or the way the model is configured. This computational simulation is, quote unquote, supposedly eventually replace experiments.
Well, yeah, so there's got to be some real opportunities for interaction between the hybrid simulation group
hybrid testing group and then sit in center. Because, I don't know, it seems like.
So in the world of real-time hybrid simulation, you gotta crank numbers fast. But the problem is every aspect of number crunching can hurt you. Whereas in high performance computing, they spread things out and they don't worry too much about communicating between the process. But hybrid simulation, everything has to go fast, but not necessarily as large as we were customarily taught about high performance computing, which is millions of degrees of freedom. But I think that's one of the major roadblocks right now about taking the next step in hybrid real-time hybrid simulation is the ability to do large-scale computations very quickly. Large scale being 20, 30, 40,000 degrees of freedom. And being able to calculate a response within 0.004 seconds. That's usually the time step that you have to complete the cycle. Right now, I think it's limited to probably maybe 500, 600 degrees of freedom. Just if you use any similar MATLAB compiled code, you have to go to another platform.
You have to be able to parallelize it.
Well, the problem when you parallelize it, you could, but then the communication between the eventually process it's a killer. Something has to be done. Maybe a multidisciplinary approach that has to be considered.
Sounds like a good research proposal.
Sounds like a good proposal.
I think the other thing someone mentioned, trying to get the community to gain confidence in hybrid simulation. And Steve Mahan has done a lot of work in this. He keeps telling me every year how many years he's worked on it, but he's been working on it probably 40, 50 years. Hybrid simulation, and he had a point I think was right. He said that you really have to have a big demonstration project in hybrid simulation that you get an answer that's shown to be accurate and yet very impressive with what you can do with hybrid simulation. Now, that may not be emerging. I mean, it's a tool, but it's something that is going to definitely require advancements in order to get to where we have to get. I think it's more on the computational part, than the actuator control is another issue. I think the innovation schemes and that stuff are fine, but it's really the computational side is kind of the biggest hurdle at this point.
So Jim, to really make everybody believe hybrid simulation, I believe it. And
like climate change.
They just take the arm past the these projects, these wood, and then just do part of it, and then just to prove it. And then on that, with that, and then I was thinking about these soft. I say, how's the hybrid simulation campaign to collapse?
Sure. We tend to not have done so much of that. You end up.
Those that was doing something.
You in the laboratory end up with some limitations on stroke, things like that.
You'd be surprised the velocity you have to develop, almost a meter a second in dampers near it being collapsed. I think in hybrid simulation, you almost have a way to have the actuators kind of release the specimen so as it really takes off, and it's on the down slope, it's definitely collapsed. So you don't damage your equipment. We've had to actually stop test that on the verge of collapse because it was either going to impact the actuator or it was going to pull the actuator out because the velocity was large near the end of the stroke.
Do you think there's a need to simulate collapse?
I mean, I think there's a practical need, but it's very hard. Like, for example, a lot of the department of SC7 testing, event code is moving to with a uniform risk, right? What they use is the fragility curves for collapse for that region and all that, but then if you really dig into it, it's still assumed the drift event. But for us, we all know, not that many people, my system actually collapsed at that drift. In fact, to me, I mean, I think collapse is actually a topic where nobody really knows too much. Yeah, you can numerical model it, either you assign an arbitrary drift in it, or you wait for your program to blow up. But to actually really actual collapse, I think those
So,
analytically.
Do you mean how we define collapse in a numerical simulation?
Well, I think it's got all those parts of it.
Okay.
You know,
Yeah.
simulating, modeling, actually defining
But
collapse
it's quite
technology.
subjective,
Yeah.
I'm saying.
Yeah. And a lot of the models we have really aren't really meant to go to those levels of information. Even good models are not necessarily collapse models. Yeah. Other ideas?
Debris loading.
I'm sorry, second?
Debris loading
Oh, debris loading, yeah.
following to tsunami or following to flood.
Yeah,
Tsunami for the buildings and for flood for
Right.
the bridge.
yeah, Jim Rickles showed one video that we did from some debris loading tests that were done here by Clay Nida, but there's certainly a lot more that could be done. I mean, they could develop some information to go into ASC 7 based on that, but it's just like the beginning of the topic, I think.
And effect of composite action on the seismic behavior of a structure. Composite action is investigated, especially for conditions.
You mean steel concrete composite?
Yes.
Yeah, I think it's steel structures. So, we're running out of time. I'm not paying attention to time.
About 10 minutes.
10 minutes. We've been going for
No, we have about 10 minutes.
10 minutes.
We have about 10 minutes more.
About 10 minutes more? Oh, well, we should probably look at
We
the
should
other
have
questions.
17 minutes more, right?
Well, yeah, but I think it's
Oh, you're going to end at
I
6?
think we're fading. Skip to 6.
Well, we gotta move back to the topic.
Okay.
Yeah. So,
You can leave the lights on if you want to keep.
let's go, let's actually go on to the second, the third topic, actually, just in terms of where NHERI facilities fit into these. It doesn't just have to be the Lehigh one, but, so what are some things that,
I'll edit that.
yeah, what are some things that we should be thinking about doing experiments on that would relate to the challenges?
NHERI is supposed to be multi-hazard, right? So that's a major thing to adopt to multi-hazard testing.
There are a lot of seismic stuff here today.
Yeah, I mean,
Yeah.
that's a one major change that we have to go through.
Yeah, so figuring out how to do other hazards besides earthquakes, I think, other hazards besides earthquakes. Yeah. Someone mentioned hybrid winds, for example.
Yeah, that I know.
Hybrid wind would be a example. At UCSD, they have wind loading inside.
I think we do wind following earthquake.
What are some other things? What are some other things we can think about from the facilities and testing kind of concepts?
It seems like there's still a lot more opportunity to integrate geotechnical things with structure.
Yeah.
Yeah, that's something you guys
were big.
Yeah.
Might have been
successful.
Yeah. How much does it cost to build those soil boxes?
They nearly 100,000.
Yeah.
The laminar soil balls.
Yeah, they look expensive. Yeah,
You could buy off those.
Are they having a sale?
Sure, that.
Other ideas?
I don't know, this is more logistical, but I know they talked about more multiple institutions being a part of one project and how to coordinate more PIs, kind of
Right.
similar topics to kind of solve a bigger problem.
Right.
So kind of how do we coordinate that and network and build those relationships to solve common
Right.
problems?
Yeah, I think we've been part of a few of those, and some are easier to put together than others. And there's always budget issues with having a lot of people involved. Just the money kind of becomes difficult to sustain all those people. But, yeah, and I think it's a good point, actually. Especially the big projects that try to take on bigger issues.
I guess that's where the payloads come in too.
That would help too. Yeah.
You mentioned fire following tsunami, but how about the fire itself? It was mentioned that fire cannot be.
Just the NSF's policy, the way they're handling it for this is they don't want anything to do with fire.
The only fire I'm aware that they would even consider is, I think it's wind-driven wildfires.
And the about the tsunami effect of the nuclear power plants? Because in the East Coast or West Coast, especially West Coast, I'm not that detailed, but there are some risk of the tsunami power plants. In South Carolina, there is a nuclear power plant near the lake, not the sea. So tsunami attack to the power plants might be like Fukushima, what happened in Fukushima.
Right.
Just off the chart, is it possible to have everybody's names and addresses, so every share?
Yeah, we can share a list of attendees.
Names and email addresses?
Sure.
Right.
Yeah, that would facilitate some post workshop collaboration for sure. Yeah, that's good. Yeah.
I know we're here to talk about research, but I think facilities like this should also play, and could, and probably are, playing a big role in outreach and public relations. Like at Notre Dame, for example, we're losing students to other engineering fields. Our numbers have been going down. I've spoken with other colleagues at other universities. That may be a national trend. And I think there are reasons why structural engineering is not at the top of some young high school kids' vision for what they want to do. So if they see these kinds of exciting facilities and laboratories and experiments, this is how we sell it.
You have to think that some of the videos we saw today will be of interest, right?
I would think so. And I know you guys are doing these kinds of things, but we got to do more of it.
Yeah.
I was just talking to a friend about that like a week ago, and we kind of concluded that we feel, well, I'm one of the very few structural engineers in my school, and we feel like there's not enough money for like funding. So everyone goes to geotech because that's fairly new and there's a lot more money involved. So that's what we thought was the reason why we're going to a lot more structural engineers than anything else.
And the problem is bigger than structural, actually. I should have talked more in terms of general civil.
Yeah.
Civil is losing numbers to other engineering disciplines. I'm thinking if I was a young high school person, which is a long time ago, I mean, I probably wouldn't have gone into civil right now.
It still comes with money.
Economics perspective,
Yeah.
If you're an IT engineer, you can gain probably 3-4 times what you get as a structural engineer or any other civil probably.
Well, I don't think it's just that. I mean, it just doesn't view it as a high-tech field, which it is not.
You're right. That's true.
They're not selling it like that.
That's true.
Maybe it's in our culture because you go to Colombia or Ghana, civil engineers
It's
are
a big deal.
together with the lawyers.
So what are we missing in the US?
I don't know.
It's never been here at the top of the food chain.
I think in the old days, it was, old days meaning like not that old, but maybe 20 years ago, it was still a very prestigious field. No, it's not.
Not really, no.
I think the reason why we're not doing that much. In China, the civil engineers are like every because they do a lot of construction. And here, what's the last time Bethlehem had a new building and how significant all the single family.
Go to the casino. I don't know. It's a good point. I think that average probably could be. We do some interesting things, right?
Yeah. Talk to the ETO about that.
Yeah.
And not just outreach. I would add to
public relations work. Yeah. Every time there's an earthquake that's really damaging, then that's when the people who are news media will call up and say,
Yeah.
Right. Otherwise,
So we'll be doing that with the reps. We're gonna have the event free.
that's good. Yeah. It's needed. Oh, so any other ideas?
I think test bed structures are important too. You guys have one here. The idea that San Diego is to come up with some simple shape. So I think that's important to have. And then also tie that in with the same center, not like in terms of structures, but test beds in terms of software. And tie that together.
Yeah. We actually have two here. We have a red frame for planar frames. We also have, it's very easy to do device damper characterization tests. So we have done something that is kind of, like damper test bed, but it's pretty small. But we have those. But yeah, I think there needs to be more. When you use one of those test beds, the tests are actually fairly easy to arrange and it's pretty clear what to do and how to get the results you want. As soon as you get it to something more general and complicated, then the cost of the experiment becomes greater, and also the planning process.
I think one thing you have to be careful on those test beds, no disrespect, but sometimes they're oversimplified. Like the connections or something, and you look at it, it's not that realistic, and you find if you ever study what Richard presented, the details in the structure are important because they interact with the damper, so you don't want to oversimplify that a structural test bed that's reconfigurable and just put in rods and crevices and that's supposed to be flat hinges. So I think that it's a challenge because if you make the test bed structure too complex, like just erecting a complete new structure each time, but you do have to give that some consideration. I think that the details, like with a brace frame, you really need gusset plates, and you got to have braces there that represent the flexibility that normally may be in series with dampers and moment frames, how the loads get into the system. And you have to have some realistic details there.
Richard, I'm thinking about that. I'm involved with NSF CRISP project, looking at the interdependency between underground water distribution system and transportation system. And we also want to think about that, what impact that this may have on those interactions. I do not have a specific idea, but I'm just thinking that something could be considered as a topic that might be interesting to
right. So in the CRISP program, there's an emphasis on interdependencies among infrastructure systems and how that might be important for community resilience. And I think something people haven't looked at much, but the interaction between two infrastructure systems, especially on the physics side of it. Because CRISP also deals with other kind of interactions in terms of restoration processes and things, but on the physics side of it, there's probably some issues. Which I think among the test beds that we could consider would be test beds for non-structurals. I mean, I know there was a test bed at Buffalo at one time. It's still there.
Maybe you could find that one.
Yeah. But there's certainly a lot more emphasis on the damage to non-structural.
So one of the things we might think about is that it's kind of all experimentalists so there's all these kind of next generation models, and some of them are kind of community, they require fragility data, they require maybe some information that we're not actually collecting now, and we're not necessarily designing our tests suitably to inform what goes into those models. And so I don't know exactly how you might do things differently, but some maybe better collaborations between, well, like Paula was presented, like those types of, we got together and said, well, what kinds of information do you need to actually inform the fragilities that you use in those models, and can we develop some tests that really target those things and make those models, maximize the value of those kinds of things.
Right. That's a good point, Joe. I saw recently some papers that came out of the non-structural tests that were done at Reno a couple of years ago, and the papers are coming out now, and they come out with clear fragility information on the non-structurals that could be then used in terms of beginning to assess damage to complete buildings. So the way they presented the data, I think, was important. They kind of looked ahead to what we really needed. I think it's a good point.
Well, just as fragility is being presented in terms of repair instead of damage, you might actually lay out a test, quite a bit differently if that was your end goal, right? Produce fragility curves from that information as opposed to damage data.
Right. Well, we were. I give you an example of what you're talking about. We were interested in damage to brace frames, special concentric brace frames, and a student looking at damage, and we sort of had to disassemble some tests that were done at the University of Washington, actually. The test, one of the early sets of tests to get it into repair. We tried to figure out what would require repair actions based on the damage that was being reported. And it actually was challenging to kind of take it apart that way and look at it. Where I think if you were thinking about it, you could actually report it that way. So you could report it in terms of probability of a certain repair action instead of just damage.
There could be some opportunities for NHERI because the Sim Center and DesignSafe kind of together provide this unique, I think, link to really work across experiments, data,
simulation in a way that maybe.
But there's no reason why the experimentalist couldn't be providing interpretation of repair required.
Right.
So in all these fragility curves you guys were discussing, it's very important to see the effects of aging, for example, in the steel. You partially damage your structure. Right. And how to assess the residual capacity and how do you account for aging? Because aging will build on the steel in 3 months or so. Is it only going to take place somewhere else? Getting brittle, you remember? So all those things could be accounted for. This is the place to study the issues of steel.
Yeah, we're talking about aging of the material after damage.
Yeah, aging effects and fragility analysis.
Yeah, effective aging.
Aging in the steel.
It's particularly in the steel after you plastic.
Both reinforcing steel as well as structural steel.
Would excess snow, like the one that collapsed Hartford Coliseum and cost $70 million loss for the Civic Center in one shot, would that be considered something that NSF would consider under this umbrella, or is that something outside?
Sure, yeah, I think I was talking earlier about someone else about generally about what are some of the hazards. I think there's ice and snow loading in particular, maybe not on buildings, power systems, those kinds of systems. There's a lot of other loading that's natural that can cause damage.
How about community centers in areas where you have more tornadoes, like the Midwest, that strip? We have tornado wind speeds, ASC 7 and a few things, but you see it on the CNN, a whole bunch of houses are gone and just people are out on the streets. Shouldn't there be a solution to that somehow, or even for residential structures like residential structures? What to do with the residential structures? So people's houses won't be flying off just like that, even if it's tornado. Right. Tornado, should we have tornado resistant designs available for those who want to pay for it? Maybe.
Yeah.
Shelters. Yeah.
Shelters and shelters for poor people like me, but for rich people.
Yeah. So in the tornado prone areas of Japan, there are buildings that are designated tsunami shelters that are designed for that purpose. And some of them in the Tolgord, some of them actually were utilized and actually perform their functions. They have to be resistant to the debris impact, which was mentioned. So yeah, I can imagine there could be tornado shelters too.
I remember, I think Colorado State people had a movie in which they took a telephone pole or something like that, and they put it in a cannon and shot it at a masonry wall that was supposed to be used for a shelter.
Right.
And they kept doing it until they found empirically the thickness of the wall or something. So we can have a few cannons in your laboratory.
We did some tests of impacts of telephone poles actually here as part of the tsunami study. Not me, Clay Naito did that.
Interesting.
The one that Jim showed was a shipping container, which is much more interesting. Shakes the whole building. Other ideas? Or we running out of steam? We have to start early tomorrow, don't we? What's the schedule tomorrow?
7:15.
7:15?
7:15 breakfast, 7:30.
Breakfast. We're gonna have the Dr. Pausch.
Yeah, we're gonna call Tommy Stephens.
All right, so everyone has to be very chipper and energetic for Dr. Pausch. We're having a good workshop here, okay?
That's brilliant.
Thanks so much. I don't know what we're gonna do.
Yeah, that's fine.
You're typing away and I'm thinking, oh God, how are we gonna organize this?
That's it. I'm saying stop typing.
I did hang it just like that. That wasn't exactly. You have to scratch. So scratch 0,
So 0.
All right. I will see you tomorrow. Yeah, they are. They're countries.
Thank you. You did all the work.
Flashback, right? Yeah.
I don't know where it is.
Okay,
Swap move it afterwards.
Yeah.
I just want
All right.
They gave me $100. So you should ask him.
Yeah.
I don't think that was done by us.
I'm just gonna work on this. No, it's not that shape. You can get 3 parts. Which is chilling.
I maybe